Thank you. All right, today I'm going to be talking about KMP. So first up, just a little about me. Every summer and every Easter, anytime there's some good public holidays, my family, we all go down to Bilue, which is a lovely little town in the Mornington Peninsula in the south of Victoria. And my family, my immediate family go down, my uncle and his children go down and their children, and this ends up quite a group of people. And we always meet at this cafe, 8 a.m. every morning. And sometimes there's a couple of people, sometimes there can be like 13 people. It just depends who feels like coffee in the morning, who's not hungover from the night before, and who wants to say hi. So, there's my dad there in bright blue, my uncle there in the cap, and my nephew. Everybody joins in for family coffee. And it always happens every single day that the credit card from someone gets passed around to shout everybody a coffee. But of course, who's going to take the orders? It usually gets shoved in my direction with just fix it. And so it's up to me to remember what everybody has for their coffee. And so I thought, I'm always doing this using my notes app and writing down who's there, and I'm going to remember, I can see who's there and what they have and exactly their order. And I thought there should be a better way to do this. Surely there's an app for this. Well, I decided to make one. It's called Coffee Run. And, just so I can take the orders from my family, and the orders can be on their phones, and then I know it's the right one because it's coming from them. But I've got a problem. My immediate family is all on Android because I have to be tech support, so it has to be Android. But then my uncle and his family are all iOS. So how am I going to do this? I'm an Android developer. How am I going to write an app that works both on Android and iOS? I'm very Android. I've never written anything on iOS, but I do know a lot of Kotlin. So I can use Kotlin Multiplatform. So if you haven't looked at Kotlin Multiplatform before, it allows us to run apps on both platforms. Traditionally, with native apps, we have different layers of code. We have our UI, our domain, and data. And if we're going to be writing apps for Android and for iOS, they're going to be different because they have different languages, Kotlin and Swift, different architectures, just generally different ways of doing things. But Kotlin Multiplatform allows us to share this logic. So we can share our domain and data and write only once for both platforms. But of course, me being me, I'm like, I do not want to write any Swift. So I'm going to do Compose Multiplatform as well. And this allows me to share the UI as well. So I don't have to write any separate UI for iOS. And I could also, if I chose to, run the same app on web as well. It would be really easy to port it across to web. And if I wanted to run a backend server, I can do this as well with Kotlin Multiplatform and allow everything to be running on the same platform, same language, same sort of dependencies, and make it a lot easier. Write once and run everywhere. It's the dream of every software developer. So where can we get Kotlin Multiplatform support? There's different tiers. So JetBrains and Google work on Kotlin Multiplatform, and they put these things in different tiers of categories of support. So we have tier 1, which is fully vetted and reliable. We can use this in production. So this is where we have Android and iOS and desktop. So we can be pretty sure that if we're building a Kotlin Multiplatform app, it'll work totally fine on Android and iOS. There's tier 2. This is where we've got partially tested code. It's experimental. We might just use with caution. We're not quite sure if, everything will work perfectly. That's where Mac OS and Linux work. And tier 3. This is where web lives out in the early access only section. But gradually, these platforms are getting more and more stable, and they're moving across the tiers. So eventually, we'll have tier 1 support for all platforms. I'm just going to focus on tier 1 because I'm a native app developer, so that's all I care about. So let's get started, right? Now, spoiler alert, it was actually easier than I expected. I originally planned this talk and I thought, I'm just probably going to only make a Hello World app and just demonstrate it to you all. But I actually was able to build a full app, and it was a lot easier than I expected, especially as I am already an Android developer. It felt like just writing normal native Android code. So if you are an Android developer, This is something that, it's very easy for you to go out and do. So I'm going to focus a lot on the lessons learned during this process, just so I can give you some guidance on what you might find when you go and take on this yourself. So how do we go about this? As I said, very easy with Android. And even if you know other platforms, if you look at some of the ways you build Android, you can use those same ideas across into Kotlin Multiplatform. When we're building this, we can just use Android Studio with the JetBrains Kotlin Multiplatform plugin. We've got a new project template, which will produce a Hello World app for you. And if you want to just do a Kotlin Multiplatform module, which I'll talk a bit more about later, there's a wizard for that as well. So when we get our new project, we can just select which platforms we want to support. So we've got Android and iOS here. I've decided I'm not going to bother supporting the other ones. And I can also decide whether to share the UI or have separate UI. So if you do want to write really native experiences, you can write them in their own native platforms. You don't have to share the UI. So what do you get when you've created a Kotlin multi-platform project? Well, if you're an Android developer and you're used to Android Studio, you might think, oh, this looks quite familiar. I've got Compose app. That sounds reasonable. We've got common main and iOS main. Yeah, that kind of sounds what I need. Maybe Android and common is in this common main. That looks kind of good. There's some Kotlin files in there. iOS looks like I've got main view controller. That's an iOS thing I know. Yeah, that looks like iOS, right? That's all the things we need? No, this is the first lesson. If you're going to be playing with Kotlin Multiplatform, don't use the Android file viewer in Android Studio. You need to look at the project as a whole, because there are a lot of different files that are hidden from you in Android Studio. We can have a look up here. We've got the project viewer, and then we actually have some iOS code here. So we've got a few Swift files and the project setup files, and we like the info plist here. And we do need to use these a little bit. So you do need to know where to find them. You can't ignore the other platform completely. But if we have a look, we've got a Compose main. We also have our Android main as well. So we can write separate code for Android if we want to. So what do we share between Android and Kotlin Multiplatform? What things are easy to do? Kotlin, obviously. Gradle. So we can use our normal Gradle build system for building a Kotlin Multiplatform app, just like we might for Android. If you've looked at Gradle before, you'll see some very familiar things. We have our plugins at the top. We can see we're using the Kotlin Multiplatform plugin. You can also see that I've got the Compose Multiplatform plugin as well. Then we can specify which targets we're supporting. So we've got Android here, we've got iOS targets as well, and I've specified the iOS simulator as well. So I can list which targets I'm happy to support. I then have some platform-specific configuration. So on Android, I can use Gradle. That's totally fine. Totally normal Android, the default config, packaging, build types, all normal. But on iOS, on the other hand, I need to actually use Xcode. So I had to install Xcode. It's a bit of a problem. And so on there, we've got all the settings that you might be used to if you have done some iOS development. I don't know how to use Xcode or anything that I'm doing in here. I use Gemini a lot to help me with this. And I asked it to explain lots of things to me as if I was a 5-year-old. So that worked really well for me. So if we can use Gradle, that's pretty good. It's mostly similar. We also can use our dependencies and Jetpack that we used to for Android development. So we have our dependencies in our Gradle. We've got Android main dependencies. So these are dependencies that are specific for the Android part of the app. We have common dependencies. These are the ones that are going to be shared with iOS as well. And these are where we need to have Kotlin multi-platform specific dependencies. You might notice as well that I've got Compose here rather than our normal libs.something. This is coming from the Compose Multiplatform plugin. It allows us to access the Compose dependencies that are available for Kotlin Multiplatform directly. But where are our iOS-specific dependencies? This is where I got to my second lesson. So you can't forget about iOS entirely. I tried, and I did actually have to write some Swift code, which was traumatic. Even more traumatic was learning about Swift Package Manager. And then some of the documentation I was looking at referred to CocoaPods. And so I even went down the path of adding CocoaPods. And that was a really bad idea. All of the iOS developers I know said, why are you doing that? but I managed to get myself out of that one. And you can see how I needed to add the Firebase SDK into the iOS app with the Xcode. I eventually worked out how to do this with some help. So our Jetpack libraries, which ones can we use with Kotlin Multiplatform? Again, there's 3 different tiers. There's tiers for everything. There's stable, commonized, and alpha. So they're gradually migrating a lot of the dependencies that you might use now into Kotlin Multiplatform, so it's ready to be used for anything. So there's these different groups. So some of them are stable, happy to use them in production. Some are currently being worked on, and some are very alpha. And this is changing constantly. I recommend checking out the documentation because even this diagram is now out of date. But if we have a look at what sort of dependencies we're including, we've got our normal Android-only dependencies, and then we have our multi-platform ones. If we look at Kotlin Multiplatform, we're using the org.jetbrains naming rather than the Android X, because we need to make sure we've got the correct multi-platform library. If you try and use a standard Android library, it just won't work. You'll get all these really weird errors, or it might not even compile. But so really make sure that you're using the right dependency for multi-platform. What about non-Jetpack libraries? Well, you can use some of them that you're used to, and some you might need to pick a different one. So not everything has been ported across to Kotlin Multiplatform. So if you're used to using Retrofit, for example, now in multi-platform land, you need to use Couture client because they've built that for Kotlin Multiplatform. If you're doing dependency injection, instead of using Hilt or Dagger, we use Coin instead. They're pretty similar, but you do need to sort of learn a few more API rules or a new platform to use. But it's pretty straightforward. Some things they've already ported across and it's great, but other things you will need to go and check specifically. I recommend checking out this website, klibs.io. This will give you a whole bunch of different libraries that are enabled for Kotlin Multiplatform. And a key feature is checking to see how much of the API has been converted, because usually it's not everything. And you want to make sure that you're using what's been converted and not parts that haven't been. But take a look at that because it changes frequently and it's good to get the latest information. So this is where I got my third lesson, which was trying to integrate Firebase. And I thought, okay, my app, it's going to need a login because it's going to need to, I'm going to need different users to log into this and, store their data on Firestore. I'll use Firebase, great. Silly me, thought I'll, you do the authentication first. All right, the login screen, register screen, do authentication, that'll be easy, right? No, it wasn't. So for using multi-platform with Firebase, at the moment, you need to use the GitLive SDK. And so they have been converting Firebase across to multi-platform. Now, they're doing a great job of it. It's very, very useful, but they haven't completed it yet. And one of the other problems is they've made some choices in the way they're constructing their APIs that are just slightly different from the standard Firebase SDK. And that causes a few problems. For example, in their library, they decided to use infix notation, which is just very subtle difference. But then everything, all the documentation is using the non-infix notation with Firebase. So it can get really confusing as to what you should be doing. So in order to use this, I had to add those dependencies to common main and SPM. So this is why I needed the actual Firebase iOS SDK. I did have to do some Swift to initialize. I'll show you that when I do the demo. And yeah, as I said, integrating authentication, it was really hard. And that was because they haven't migrated most of the SDK across. The SPM package and the GitLive SDK are out of sync. And this is one of the challenges, is if you're trying to use something that depends on something else and they're not quite in sync, not everything has been ported across, you get a lot of weird errors. And this wasted about a week of my development time. And was really quite tricky. So if you have a look at the API coverage here, it's not even. It's a bit hard to see on these screens, but they've got, cloud messaging, for example, only 10% is coverage. And where was authentication? They've got 80%, but unfortunately I wanted to use that 20% that is not covered. So make sure when you're checking into these libraries and dependencies that everything you need is actually covered, because otherwise you'll end up in pain. I eventually found my way to using the bits that were covered. So we can kind of use our dependencies and Jetpack knowledge. Dependency injection, I mentioned before, you can't use Dagger and Hilt, you need to use Coin. But you can use your standard architecture patterns, anything that you're used to using when building other apps. So MVVM, clean, all that sort of thing, coroutines, all the things you might be used to. And we can use Jetpack Compose. If you're an Android developer, yay. It means you don't have to write any other type of UI. You can use the same UI, same previews that you would use on a native app. So we get our UI for everybody. So let's take a look at this. So if we have a look at my Android Studio, I'll just make sure that's big enough. Might make that a little bit bigger for you guys. There we go. So we can see that we have the project view, as I mentioned, and I've written all this logic. So there's a lot of code written here, but I only had to write it once. I didn't have to write it for both platforms. We can have a look. In our Android code, I've got my main activity that I might be used to using. Pretty simple, just has my onCreate and runs my application. So, and that's where my app starts, right? Pretty straightforward if you're used to Android. But well, how does this work for iOS? Well, in iOS land, I'm using this Swift file here. So this is opening up a content view. Oops, let's go through there. Content view here, which is then going to open up a main view controller, which is going to open up my Coffee Run application. So the iOS code will just run my application. I don't have to write much at all. And most of this comes out with the wizard anyway. I did have to write some Swift code, and that was for Firebase. So I mentioned that I did have to write this app delegate. I did make Gemini do that for me, so hopefully it works. So you don't have to write much to be able to get it going. But we can have a look what it looks like. So we can see I've got my app here. So I've got Android here on the side and then iOS on the right. So you can see the styling is the same because I'm using the same UI for both platforms. So I've got my coffee order here. Let's see if I want to go make an order, I can just go and start adding people to my order. And so I've got people for my coffee order. Now I could do things like modifying over here. So if my sister is on this one over here, she decides she wants it to be takeaway. Save that. It's using the same logic that I would be using in the other one. And unfortunately, I haven't got the refresh working, but we can see it does update as takeaway. So I'm using the same logic for updating both platforms. But one thing we can notice is as I'm navigating around the screen, on Android, you can see we've got like a sort of a dissolve effect. But on iOS, it's sliding, which is more the standard behavior from an iOS device with animations. I'm using material theming on both, so it means they both look the same. But we do get some of the native behaviors in with the app. But what about if we don't want to have everything identical? Let's have a look about that. We can use expect and actual. So this is where we can ask the API that we expect something, and then each platform will provide the actual. So it's kind of like maybe a promise or it's an interface that we're saying we have this interface and each platform needs to provide the implementation of that interface. So a simple example is when we have something like this, get platform, where I'm just going to get the name of the platform, just a string. I put this in common main. Then in my Android app, I would have the implementation of this, where I've got the actual, where we're getting the platform, got the platform name of Android. Then iOS, the same thing. We're getting the name of the platform as iOS. So it means I could put this text anywhere in my app and it would respond depending on what platform we're putting it on. But getting text is pretty easy. We don't need to worry about that too much. What about something a bit more complicated? Well, what if I want to share the app or just open up the share sheet in each of the apps? I want to have the Android share sheet in the Android app and the iOS share sheet in the iOS app. They look quite different, behave differently. I can use expect and actual again. So I can use my dependency injection using an expect that I'm going to pass in a specific module for platforms. And I'm going to have a share service. This way I can expect an entire class. So you could expect an entire implementation, an entire screen, entire view model, whatever you want to be specific for each platform. In this case, I just have one function, which is just the share app function. And then I can have the actual. So on Android, we have, I'm injecting my share service. In this case, I'm providing the Android context because I need that for my share sheet. And then the actual, I'm implementing my share app function. I'm doing the normal things. I've sort of excluded them from this diagram because we all know how it works. We've got starting our activity, creating the chooser, the things we need. But on iOS, I don't need to inject the Android context because iOS has no idea about a context and doesn't need it. So I can provide an entirely different mechanism for creating my share service. And then I'm going to use the beta interop API. So this is the interop API is allowing us to write Swift code with Kotlin. If I wanted to, I could implement this entire share service in Swift if I wanted to, but I don't have to. I can use this interop API, which provides a way of calling Swift code. So we have all the classes we might be used to in Swift. So I'm creating a share sheet just like I would in Swift, but it's actually in Kotlin code, and then it gets transpiled into Swift code on the device. So I can create my share service using the native iOS behavior. So then when I'm displaying it on each platform, I've got the Android version, what we might be used to, and then the iOS version. We can see that I've even got different text in both ones, depending on what I want to show. So using these mechanisms, you can show different screens, different behaviors, depending on which platform you're running at your choice. You might only do it for one platform, or you might do it for all of the ones you support. So the adoption can be on your terms. You can decide which parts you want to be in multi-platform land and which parts you want to be in native land. You can use as much or as little Compose Multiplatform as you like. You could actually embed Compose in Swift UI or Swift UI in Compose as you want. You get really confusing, but you can embed them all in each other. And it gives you actually full backwards compatibility to older versions of the operating systems, which is really powerful. So some recommendations if you're going to go and try Kotlin Multiplatform. Start really simple. Start with a really simple app. Don't start with authentication like I did. If you have an existing app, you can actually migrate module by module. You can just convert some of your modules into multi-platform modules, and later on decide if you want to migrate the rest of the UI or the other layers. But if you're building something new, you can just migrate them one by one. And you think that if you're an Android developer, focus on Android first, right? This is another lesson that I had. Test on all platforms constantly. I was actually testing this app before doing this talk, and I thought, oh yeah, just check a few things are working. I've got my register screen here. I put in a small password. I got this password message. Yep, that looks great. When I tried it on iOS, I got this very, very ugly message. Definitely not what I want to show to the end user. I was like, why is that happening? It's using an API that is available for multi-platform. Well, the trouble was that it wasn't implemented the same for both platforms. So when I was looking at it from when that exception comes up on iOS, it doesn't have that nice human readable error. So it means if I hadn't tested this, I wouldn't know this. My end users would be seeing this. And so what I had to do was go and handle those exceptions correctly and provide my own message. But it means that even if you're writing a multi-platform application and saving a lot of development time by only having to write code once, you still do need to test on both platforms because they will behave slightly differently. You might get slightly different notifications, slightly different messaging, and that depends on what dependencies you're using and things like that. But you never know what might be slightly different. So you do need to test on both. You can't just rely on just testing one platform. So you need to make sure you're testing on all platforms constantly. I'm constantly being surprised when they behave ever so slightly differently. But if you are starting a new app, I recommend just build for Kotlin Multiplatform anyway, because it means in the future you have options to do multi-platform. You might just build it for Android right now, and just deploy it on the Play Store. But then you could convert it into an iOS app very easily later. And if you are doing this, find your friends that know iOS already. In Melbourne, we have a coding night where we share with Coca Heads, the iOS group. And I go along to that and I grab all the iOS people and get them to help me fix my problems because I don't want to learn any of that stuff. So you want to find people who are already experts in the platform that you're not used to, and get help from them. Say, what does this error message mean? Things like that, because if you're not used to it, it can be really hard to get onto a new platform. Also, I found Gemini surprisingly helpful. I thought, oh no, it's not going to know anything about iOS or anything about Kotlin Multiplatform, but it did. I asked it frequently to explain things to me like I was a 5-year-old, but that worked. That worked very well. And I even got it to tell me how to set up various things in Xcode. Some interesting libraries to look at that are coming in the Kotlin Multiplatform space. There's this one here called Calf. I haven't tried these yet, but this one will actually give you a native look and feel depending on each platform. So they're actually re-implementing in Compose the iOS native date picker and the native dialogue style, so that it makes your app feel more like it is native to that platform, rather than having what I had, it was just a carbon copy on both. Another one is Atlas, and I've seen a few of these all-in-one libraries. They have a lot of implementations for different functionality that work on both platforms. So putting that, like, expect an actual demonstration with the share, that they've got that all of these libraries. Again, I haven't used this one, but it's a really interesting space to see. There's lots of these big libraries coming which implement a lot of the stuff to work on both platforms. One of the recommendations would be take a look at how often these are being updated and who is doing the updating, because you don't want to be stuck on something that doesn't have the latest features and you're sort of tied into a particular library. But it's an interesting space. So we're ready to go for a copy run with iOS and Android. My nephew he's a big fan of a baby chino. Here's some useful links. Mostly check out jetbrains.com and the Google Kotlin developer docs. There's a whole bunch there. You can grab the links to these slides in a moment, so you can grab these from there. Lots of good documentation out there now. And any questions?